Graphing quadratics using X-Intercepts. When the graph of a quadratic function has at least one X-intercept, the function can be written in intercept form. So what that looks like is f of x equals a times x minus p times x minus q. And then, of course, a cannot equal 0. Another way to think about this is the factored form of a quadratic. Okay, so it's in factored form. Some properties of intercept form is because f of p equals 0 and f of q equals 0, p and q are the x-intercepts of the graph of the function. So our p could be here, and then our q could be on the other side here. P and q are x-intercepts. The axis of symmetry is halfway between p and q. So if we have 2 points here on our parabola, we know that the axis of symmetry has to be halfway between. So therefore, the axis of symmetry is x equals p plus q over 2. It's the mean between those 2 points. The parabola opens up, we know this from just previously, is when it's positive, a is greater than 0, and opens down when a is less than 0. So I graph this parabola. Okay, so here are our x-intercepts. So once you see this factored form, intercept form, just plot the x-intercepts and then find the halfway point. You can usually count it. So the axis of symmetry here is x equals p plus q over 2. So this is our axis of symmetry. So let's do an example. Graphing a quadratic in intercept form. So we have negative 2 times x plus 3 times x minus 1. We want to label the x-intercepts, the vertex, and the axis of symmetry. So we need to identify the x-intercepts first. So this is x plus 3 times x minus 1. And so you can either think about using the zero product property. Remember that they're opposite signs, because if you're looking at this equation up here, x minus p, x minus q, it's just p and q, the opposite signs. Now thinking about just the opposite number, x plus 3, what makes that 0 inside? Well, that's going to be a negative 3. So negative 3. So that is negative 3 comma 0. And then for this one on the right, that is going to be a positive 1, 0. Think about zero product property. You set each piece equal to 0 and solve. That's really what we're doing. Okay? So x equals negative 3. On this side, x equals a positive 1. Right? And that's exactly where our intercepts are. So plot those points, negative 3 and a positive 1. So we can find the coordinates of the vertex. So one way to do this is do the p plus q over 2. Another way that I want you to think about is just find the halfway point between these 2 points. If they're points on a parabola, then the axis of symmetry has to be right between it. So how many is it away? So 1, 2, 3, 4. So the halfway point will be negative 1. So let's do that algebraically over here on this side. So p plus q. So we plug in negative 3 and then plus a positive 1, right? X equals 1 over 2. This is negative 3 plus 1 is a negative 2 over 2, which is a negative 1. Then in order to find our y value, we take this negative 1 and we plug it into the original function, just like we do with standard form. So this is negative 2 times negative 1 plus 3, negative 1 plus 3, and then times negative 1 minus 1. So let's simplify that a little bit. So negative 2 in the front, we have negative 1 plus 3, that is a positive 2. Negative 1 minus 1, that is a negative 2, and we multiply through. So negative 2 times 2 is a negative 4 times negative 2, which is a positive 8. So that's our y value of our vertex. So therefore, our vertex is at negative 1, 8. So we can, the axis of symmetry we know is at x equals x equals negative 1. And so we draw that line, x equals negative 1. And then we know that our vertex is at positive 8. Okay, here. So we can either plug in a point You can plug in f of 0 in order to solve for another point, or we can use our pattern. So if we plug in 0, it's negative 2 times 0 plus 3 is 0, and 0 minus 1 is negative 1. So that would be negative 6 times negative 1, which is a positive 6. Okay, now if I use the pattern 1, 3, 5, I multiply the a value of negative 2 to the front. So therefore negative 2, negative 6, and negative 10. So let's use the pattern. So from our vertex, we go right 1, and then the negative 2 down 2, right 1, down 6, and look, that's where the point is that I got, and so I know it's correct. Then I can go right 1, down 10, and this actually fits on the graph. So fit as many dots that will fit on your plane. Okay, so here is the graph of negative 2, x plus 3 times x minus 1. So let me write a couple things in here so you can pause the video, see if you can write out what are the similarities and differences of each. So pause the video, and when you come back, I'll have the answers for you. Okay, so here's a summary of some similarities and differences of vertex, standard, and intercept form. Now for vertex form, remember that you can just read the vertex. There's not a whole lot of calculating. For standard form, you have to use the negative b over 2a. That gets us our axis of symmetry. Then to find the y value, you just plug it back in to the original equation to solve for it. Then for intercept form, you can use the axis symmetry, which is x equals p plus q over 2, or just count and find the halfway point between those two intercepts. For both standard form and intercept form, it's similar because you just plug in the x to find the y value of the vertex. Now for all three of them, once you find the vertex and you plot it and you draw your axis of symmetry, you can either plug in a point near the vertex, so 1 to the right, or 2 to the right, or 1 to the left, 2 to the left, or you can just use the pattern of 1, 3, 5. Just multiply whatever a value is in the front. So just to get a little bit more practice, try these two. Graph each function, f of x equals negative x plus 1 and x plus 5. And then try number 60 as well. Pause the video, and when you come back, I'll have the answer for you. Okay, if you try this out, number 6, this is the graph you should get. The vertex is at negative 3, positive 4. So remember that the x-intercepts are here at negative 1 and negative 5. What you do is you set each piece equal to 0, and you solve. Or some of you can read it immediately. It's just the opposite signs, negative 1 and negative 5. So I plotted those 2 points. Now you have the option of either using the p plus q over 2, which gets you negative 3, or if you just count and find the halfway point between these 2 points. If you count, you notice that negative 3 is your x value or your axis of symmetry. So axis of symmetry is x equals negative 3. Once you find that, by either calculating it or by counting, you can plug it in into the original equation to find your y value. So notice I plugged it in, negative 3. So negative times negative 3 plus 1 times negative 3 plus 5, you get negative negative 2 times 2, which is a positive 4. Then from here, I apply my pattern. I have to apply a negative to the front. So it's right 1, down 1, right 1, down 3, right 1, down 5. And notice that's where I found my y-intercept. Remember, the y-intercept is when x equals 0, right? So at this point here, x is 0, y is negative 5. For the next one, you can apply the transformations. So looking at this, you can see that you have negative 4, that's a vertical stretch by 4, and this negative 7 is right 7. So we just move right 7, plot our point there, that's our vertex. We draw our axis of symmetry at x equals 7. We know that's our x-intercept as well as our vertex. Then we apply the pattern to find more points. So 4 times 1, 3, 5, so it's 4, 12, and 20. So right 1 up 4, then you go right 1 up 12, and it doesn't fit, but make sure you reflect that point so you show how many points are there. So I hope this helps. Thanks for watching.